Hi everyone. In the last session, we have seen how to traverse a double linked list in forward direction as well as in reverse direction. Now in this session, we'll be discussing how we can perform insertion operation in a double linked list, right? So insertion operation in double linked list, or not only double linked list, in single linked list or double linked list, we can perform in four ways, right? Inserting a node at beginning, inserting a node at end, inserting a node after a particular node, inserting a node before a particular node. These are the four ways we divided insertion operation into four subcategories like this. Why we divided means, in order to make you understand the concept clearly, we divided insertion operation into four sub operations. And these four sub operations in your program represented by using four functions. One is insert underscore first, which is used to insert a node as a first node. Insert underscore last, which is used to insert a node as a last node. Insert underscore after, which is used to insert a node after a given node. Insert underscore before, which is used to insert a node before any given node. Like this, insertion operation has been divided into four functions, and these four functions we are implementing in our C program, right? So let us see one by one function clearly, how we are going to perform in inserting a node as a first node, right? So these are the steps that we need to follow in order to insert a new node as a first node. The first step is what? Creating a node. And after creating a node, we need to check whether the double linked list is empty or not. If double linked list is empty, then assign a new node to what? Start pointer. Then we need to assign a new node. That means whatever the node that we created, and that node we need to assign to what? Start pointer, right? Suppose if already list is there, then what we need to do is our newly created node has to become what? First node. That's what the fifth step is saying, right? The first step is we need to create the node. Second step is we need to check whether the double linked list is empty or not. If it is empty, we need to create a new node, and that new node should be assigned to what? Start. If list is already there in the double linked list, then we need to create a node, and that node should be what? First node in the linked list, right? So let us see one by one step clearly, so that you might be getting some clarity. The first step is what? Creating a node. We already come across this step in what? Creating a double linked list, right? So creating a node means allocating block of memory and dividing that into what? Three fields, right? So with the help of this instruction, right, malloc size of struct delinked, and before that we'll be taking typecast operator. With the help of this instruction, we are going to allocate block of memory. And here malloc function what takes the size of struct delink as an argument, and size of operator used to find out how many number of what members are there in delink, and how much memory each and every member takes. So total memory for this delink required is what? 12 bytes. So malloc of size of gives what? 12. Malloc of 12 means it allocates 12 bytes of memory, and that has been divided into what? Three blocks: D-link, data, and then F-link. As per this instruction, it is going to divide that into what? Three blocks. And the address is going to be stored in what? New node. And the address of the node is going to be 1000, and that 1000 address is stored in what? New node, right? So this is how we are going to allocate block of memory. After allocating block of memory, we need to accept the data part by using scanf function. Scanf %d ampersand of new node arrow data will be accepting the data part. And remaining two parts, that is B-link and F-link, we are assigning what? Null, like this, right? After what? Creating a node, we need to check whether your double linked list is empty or not, right? And how to check it, how the double linked list is empty or not, and how we can check it means, at the time of declaring the structure, we are taking null in start pointer, right? When we are going to call this insert first function, and we need to check a condition that start contains null, means simply what we need to do is our newly created node address should be stored in start pointer, like this. A newly created node, what address should be stored in what? Start pointer, right? So finally, if you are creating the first node with the help of insert first function, this is how your double linked list is going to be appeared. And these are the instructions that we are executed: allocating block of memory, accepting data part, assigning null to the link part, and then we are checking whether we are creating the first node. If we are creating first node and new node address, I'm storing in what? Start pointer. Right? So this is how what insert first function works when your double linked list is empty. Right? Suppose your double linked list consists of some nodes. Let us assume your double linked list consists of two nodes, in which the first node address is stored in start pointer, First node address is stored in what? Start pointer. And first node forward link contains address as 2000, and 2000 backward link contains address as what? 1000, and 2000 forward link contains what? Null. This is what the list that we have. Now what we would like to do is we would like to insert a new node as a first node. We would like to insert a new node as what? First node in the linked list. So for that purpose, what we need to do is, with the help of this instructions, I need to allocate a block of memory. I need to allocate what? A block of memory with the help of instruction, right? After allocating block of memory, will be what having new block of memory address as what? 3000, and that has been stored in what? New node, and the data part is what? 30. Now what I would like to do is, I'd like to place this 3000 node as first node in the double linked list. First node in the double linked list. That means I would like to make this new node as first node in the double linked list. And for that purpose, we need to follow, we need to go with some instructions. These are the instructions that we are going to use in order to establish the links between what 1000 node and 3000 node. Just we'll be seeing these instructions clearly so that you will be understanding it, what is our intention, right? 3 instructions that we are going to follow, like what? Simply let us keep these instructions aside. Now I would like to make this 3000 node as what? First node, right? So what I would like to do, or else I would like to establish the links between 3000 node and 1000 node. And you know that 1000 node is stored in start pointer, and 3000 is stored in what? New node. Between new node and start, I would like to establish the links. How I can establish? Very simple. Forward link of new node should contain 1000, which is stored in start, and 1000 backward link should contain what? New node, that is 3000, which is nothing but what? New node, right? This, like this, we need to establish the instructions. In order, like this, we need to establish the links. In order to establish the links, we'll be using those 3 instructions. In that, the first instruction is new node arrow link forward link is assigned with what? Start. Just see here, new node forward link assigned with what? Start. Start means what here? 1000. New node forward link means what here? Null we have actually, and this null is replaced with what? 1000. So that what happens in forward link of 3000, that is new node, will be having what? 1000. A link will be established from 3000 node to what? 1000 node. That means a forward link has been established from new node to what? 1000 node. Now we need to establish a backward link from 1000 node to what? 3000 node. And for that purpose, we'll be going with the second instruction, start backward link assigned with what? New node. Start backward link assigned with new node means here new node is what? 3000. Start backward link means what here? We have null actually, and this null is replaced with what? 3000. Null is replaced with what? 3000. That means in the place of B link, we'll be having 3000, so that there will be a link from what? 1000 node to what? 3000 node. 1000 node to what? 3000 node. Now later what we need to do is, we need to make start actually contains 1000, and we would like to make this new node as what? The start node, right? So new node as what? First node. If you want to make this new node as first node, means this address should be stored in start pointer, right? So start is assigned with what? New node, the last instruction, and then 3000 is going to be stored in what? Start. So that what happens here, in the place of 1000, you'll be having what? 3000. So that a link will be established from start to what? 3000. Like that will be establishing the links, and this is the final linked list, that is 30 node. We inserted as what? First node in the linked list, whereas this 3000 is going to be stored in the start pointer, right? So that is what this is how we are going to perform what insertion operation, that is inserting a node as what? First node, right? Let us have a look on coding part, and void space insert underscore first. We'll be taking one pointer, struct d-link space star new node, and then we are allocating block of memory, accepting the block data part, assigning null to the link part. After that, we'll be checking start equal to null or not. If at all start equal to null, newly created node address I'm going to store in what? Start, and then I'm going to print some message that new node is created. And later, if that condition is false, means then what we'll be doing is start is going to be stored in what? New node forward link, and new node start backward link should contain what? New node, and then new node should be what? Assigned to what? Start. And then we'll be giving some message that new node is inserted as what? First node, right? So this is how your what insertion inserting a node as a first node can be done, right? So in coming videos, I will be discussing how to insert a node as a last node, right? I hope everyone understood it. Thank you.